So hello guys, welcome to my YouTube channel. Today we are going to look into specific library called as Numpy, which is basically used along with pandas for data analysis kind of tasks. So I have the complete code snippet written on a Jupyter notebook. I will start sharing them and I will list down all the topics that we are going to talk about. So you will see a box mentioning all the topics that we are going to discuss. So the next lecture would focus on statistics as well, a few of the concepts of statistics, and then I will also cover pandas in this particular playlist. You will be able to have all those things that are relevant to Python. So let's get started with the video. So this is the notebook where I have listed all the most of the functions that are from Numpy library. So basically, if you see Numpy, how do you install it? Okay, you can just put this pip install Numpy, basic thing which everyone would know. Next is import the Numpy library. In Numpy we have the concept called as arrays. Generally in Python we only have the concept of list, which is not as fast as Numpy arrays. Okay, the reason behind is, if you see in list, let's take some 4 values, 1, 2, 3 and 4. Okay, so all these 4 values will be present in 4 different places of the memory, and these places has to be mapped with a link. Okay, for example, if this 1 and 2 is there, these two has to be linked with a link. Okay, so the memory, the kind of data that is stored in the list is not very sequential, but when it comes to an array, for example, you are declaring an array of size 10, assume a declare of array of size 10. So now we have value like 1, 2, 3, 4, 5, 6, 7. So in the memory, how it is being stored is, it's say this is the address 1000. Okay, so the value 2 gets stored in 1004. Okay, if it's a 4-bit addressing, you will get it will store in 4. If it is 8, then it will be stored in 8. Okay, so let me assume this is a 4-bit addressing, and the first values will be stored in 1000. The second value will be stored in 1004, 1008. So what happens is the data is completely sequentially allocated. The memory is sequentially allocated, hence making it much faster compared to list. Okay, so basically arrays are much faster than list. So how do you declare an array in Numpy? So we have imported the Numpy library. Use the keyword array, and you could either pass a list or a tuple. Okay. Finally, when you print it, you will get the array, the values with the array format. Okay. Next is, if you see here, this is the array, and when I print the type of this array, we can see that it got converted into a n-dimensional array in the Numpy object. Okay. Next is 2D arrays. In 2D arrays, how are they different? Okay, so what you are seeing here is a 1D array, which is 1D in the sense it is 1 dimension. Here it is 2 dimensions. Okay, we have 2 different entities, which means 2 objects, so which means there are 2 dimensional data. This is how you declare a 2-dimensional data, where a list contains 2 lists. Okay, when I print it, we can see there are 2 rows and 2 rows and 3 columns. Okay, next is 3D arrays. So same way we have defined 2 here, we are going to define 3 list. Okay, so which means when I print this, I will have 2 data. For example, what do you say? Array of 1, this is an 1D list. This is how you index. Array of, this is how you index a 2D list. Okay, this is how you index a 3D list. So this is how it is being organized. Like, we could see the data that is being printed in the 3D format in a 3-dimensional space. Okay, next is, how do you find out the dimension of the array? What do you mean by the dimension of the array, first of all? So given this array, the system has to find out what is the dimension, right? So we know it is a 3D array as we have defined it here, but we have an internal function called as ndim, which tells us what kind of array is this. Okay, so ndim tells this particular array is a 3D array. Next is, we can have n-dimensional arrays. There is no limit on that mostly. So next is indexing in 1-dimensional array. So like I told, how do you index this element? Array of 0, because this is 0th index, first, second, third, fourth. So whatever I want, I can just put array of that index here. Same way 2D arrays. How do you index it? What do you mean by array of 0, 1? We can see there is a 2D array declared, and I want to pick the 0, 1. What do you mean by 0, 1? So this is 0, this is 1 here. So 0, we are going to pick this first, and from here I'm going to pick, there are 1, 2, 3, 4, 5, right? So from here I'm going to pick the first index value. Understand, this is not the first index, this is 0th index, this is the first index. So we are going to pick 2, and you are going to return the value 2 here. Okay. Next is indexing in 3D arrays. Same way, we have 3 list defined here, which is basically a 3-dimensional array. We are going to pick the 0, which is 0 here. So this one, okay, and we have in this I have to pick the first one, which is basically this 4 5 6, and from here I have to pick 6, which is the second element of this list. Okay, which means totally there are the value is 6 here. That is what it points to. Next is slicing in 1D arrays. What do you mean by slicing? We can pick a specific range of elements or a specific set of elements that you need alone. Okay, if you see here, this is an 1-dimensional array which is declared 1 is to 5, which means 0th index this is, so we avoid this 1 2 3 4 5. Okay, so but we pick only these 3 values, which means we are picking 2 3 4 5. Okay, next is negative indexing. In Python we have the ability of doing negative indexing. Let's assume this is the 1D array. We are doing array of -1. What would it go? In other languages this will be an error. Okay, but in Python what it does is it goes to the last element and tells, hey, this is 7. Okay, that is what it does. Next is negative slicing. What is meant by negative slicing? Slicing based on the negative index values. If you see here, this is -3 and -1. We want to pick the values between this. Okay, so -1 is this, -2 is this, -3 is this. I want to pick the values in this range. Okay, so I will pick 5 and 6, but I will leave 7. Okay, this is -3, this is -2. I'm leaving out -1. Okay, even though the range is -3 to 1. That is how you have to define the range of a list slicing, array slicing. Next is slicing in steps. How do you slice in steps? What do you mean by slicing in steps? Printing from index 1 to 5. What is mentioned here? 1 5. This is what I have to slice, leaving 2 elements. Okay, leaving 2 elements in between. Okay, just avoid this, which means from 1 to 5, this is 0th index, so leave it 1 2 3 4 5. Okay, now I will print this 2. As they have mentioned 2 here, I am leaving out an element. Okay, 1 2, I leave these 2 elements and then go print the 4. Okay, next the ranging is only till this. Okay, so you don't have to print this 1 to 5. You don't have to print the 5th element. Okay, we are taking only 2 and 4 by slicing the 1D list. Next is slicing in steps, which means here I am not specifying any range, but I am leaving 2 elements before. Okay, 1 3 5 7. I am leaving out 1 element in between, which means the distance is this element plus this element makes it 2. So I pick this element 1 2. Okay, I reach the count of 2. Now I will pick this element 1 2, pick this element 1 2, pick this element. Okay, so basically 1 3 5 7 is the value that you got here. Next is slicing in 2D. Same as what we see in 1D, slicing in 2D is as well. Nothing is going to be different. If you see here, 0 1, so this is the 0, this is the 1th index. So they have mentioned 1 here. Let me pick this one. 1 to 4, this is 0th index, leave this. So 1 2 3 4. Okay, so let me pick 7 8 9 alone. So 7 8 9 is printed here. Okay, next is data types in Numpy. In data types, we have the following format. I stands for integer, boolean, unsigned integer. What do you mean by unsigned integer? Which is of a specific range. There is no unsigned integers doesn't let us to have like values lesser than 0. There is a specific range for this. Okay, next is float, complex float. Complex, right, like 3 plus ij, all that. Time delta, date and time, object, string, Unicode string, fixed chunk of memory for other type void. So these are the different data types that's in Numpy. Okay, so what are all the array types? Okay, first we are the same way, we are just declaring, passing a list to get an Numpy array. Next is I'm printing the type, which means it goes and takes this, tells that this has been converted to an n-dimensional array in Numpy format. Next is, if I only index this particular element, which is of 0th index, what it tells is this is a Numpy array, but I have to ask about only this element. So this is an integer, okay, which is of 32-bit type. Okay, so it tells Numpy integer of 32-bit type. Also array of D type. What does D type means? It means data type. So there are 2 ways. One is like you are doing a type of array. This is one way, and another is array of D type. Okay, so when I do type of array, you can see that the result that we are getting is this is an n-dimensional array. When I do array of D type, data type, it tells it is integer 32. Okay, fine. Next is each element is a byte string. Here I can mention this is a byte string. So I have passed a list containing integers to form an array, and I have mentioned the data type as yes. This yes means this is a byte string. Okay. If you see here, now I got the array which is being shown like this. This B stands for byte string. That is how it is mentioned. Next is array.d type. Represents each element in a byte string of length 1. Okay. So each element in this array is a byte string of having length 1. Okay. That is what it means. Next is data type 4 bytes integer. So here same way passing a list mentioning that this is an I4. What does I stand for? Let's go and find out here. It is an integer. So what does 4 stands for? Okay, it is a 4 byte, which means array.d type. So integer 32. Next is converting a data type. Here we have a list containing float values. I wanted to convert everything to integer. So I can just put as type command and then mention the I, which means this will be an integer. Next is print new of array, print which prints the actual value. We can see that the float values have been converted to int values because we have mentioned this. Next is d type, which is telling the actual data type, that after conversion it become an int kind of a values. Next is Numpy. We have two commands called as Numpy copy versus Numpy view. Okay, let's find out what is the difference between copying a Numpy array and copying a Numpy viewing a Numpy array. Okay, so let's create an original array where we are passing a list to create an array. Next is copied. We use this command original array dot copy, which means it copies the value into copied array. This is a view array next, where I'm just creating a view of what is present here. Okay, let's change an element in the original array. For example, if I'm going to change an element in the original array, which means 0th index is turned to 10. Here I'm replacing 1 with 10. Basically now the data is 3, 4, 5. This is how the data looks like. Okay, now if I print these three values, the original array is, after replacing, you get 10, 2, 3, 4, 5. But the copied array is not changed, but the view array is changed, which means the copied array does not change based on the operations. View refers to the same original array. Okay. Next is shape of the array. So if you see here, we have a two-dimensional array which is mentioned here. So 2, 4 shape is 2, 4, which means this is a two-dimensional and each having 4 values. Okay, which is what 2, 4 means, and dimension means 2, as you know before. Next is reshape function. We have defined a 1D list here, and I have mentioned reshape it back to 4, 3, which means, what I mean is, have 4 rows and 3 columns. Okay, so basically there is a 4 row here and there is 3 columns here. Okay, that is how it had been reshaped it. Next is iterating a 1D array. How do you iterate an 1D array? So array is equal to np.array, basically passing a list. 1D array, how do I print it? For x in array, print x. 2D array, for x in array, print x. But here it will only print the values of 1, 2, 3, 4, 5, 6. Each and every individual value is not printed. How do you do that? So for x in array, which means it goes and starts doing this. And for y in x, so this is x. For y in x, in the sense, it now goes and prints each and every value. That you can see that like here. Okay. So next is 3D. Same way, if you see for 3D, there are 3 dimensional elements, which means like 3 loops are present here. We can see that 3 loops are present here, basically causing order of n cube time complexity. Okay, I don't want to mention all this time complexity here. I will teach them in a separate lecture. But just know that this has 3 loops and there are order of n cube time complexity. Okay. If you see here, I'm just printing all the values. Okay. But think of one thing. Here 1, 2, 3, you were able to put some 3 loops and get the data. Tomorrow, say you have some n-dimensional matrix or array. Where you have a lot of rows and columns. Would you want to put some 10, for example, it's a 100D, basically it won't be, but if it is a 100D, would you want to put 100 loops and make it too heavy for the system to run? So that is why we have different functions like iteration functions within Python. which we will see next. Okay, so the first function that we will be seeing is nd iter function, which means we need to use n for loops which can be difficult to write for arrays with high dimensionality, so this can be used. Okay, which basically means, for example, there is an n dimensional array which is defined. We can just simply use this nd iter function, pass the specific array, and then print this easily instead of putting some n loops here. The next function that we have is nd enumerate. Okay, same way I'm passing this array here, and I'm getting the index also along with the x points to the values and idx points to the index of the values. Okay, next is concatenate in Numpy. Array 1, array 2. Okay, I have defined two arrays where I'm passing two lists. I want to concatenate this. Use the simple concatenate array 1 comma array 2 to get the two values concatenated. Next is join two 2D arrays along rows axis is equal to 1. Okay, so join two 2D arrays, which means this is a 2D array. Okay, I have mentioned that axis is equal to 1, which means I want to concatenate it based on the rows. Okay, which I have mentioned here as well. Okay, what happens when I concatenate this? Okay, 1 2 3 4 1 2 3 4. See, well, it is not defined as 1 2 3 4. That is what it means, like rows. Okay, it is defined as 1 2 3 4 1 2 3 4. It became 1, and the next it became 1, and it got concatenated in the row fashion. Okay, here it got this is a separate one, this is a separate one, which got concatenated as rows. Okay, next is join two 2D along calls. Okay, along the columns. Okay, which means here what happens, you will get 1 2 5 6. Okay, okay, there is some confusion. So what do you see here? How do you concatenate? I have defined two. Next is join 2D arrays along the axis x is equal to 0. Okay, which means I am passing the axis is equal to 0. Okay, here I have not executed with 0, so you are seeing this result. But if I have put this 0 here, the result would look different. Okay, because it is going to be concatenated based on the column values. Okay, columns. Next is split. How do you split an array? Array split. You could just use this command where I pass the specific array and tell it to split into three different parts. Tell it to split into three different parts. 1 comma 2, array of 3 comma 4, array of 5 comma 6. Okay, next is this is a simple filter. Wherever array of is equal to 4, wherever you see this element 4, just that is what gets stored here, which means 0 1 2 3 4 5 6. In the index 3 5 and 6, I can see the element 4, which is what this does, and it gives me an array. Okay, next is search even value indexes. Same way, what I do here, array mod 2 is equal to 0, basically the even condition that we use. So if this element is even, 1 2 3 4. Okay, that is what it does here. So 1 3 5 7, okay, is the index of those elements which are positive. Same way, how do you sort an array? Basically do np.sort and you will get it sorted. Sorting a boolean array, why false comes, false has the value 0, and then true has the value 1 1. So basically that is how false comes first after sorting. Array.filter, which means array is equal to np.array. I have declared. Next is x is equal to true false. Okay, now new array is equal to array of x. Okay, I'm creating a new array which is going to be an array of x. What does it mean? Okay, true maps to 41, false maps to 42, true 43, false. So what I'm doing, I will only get 41 43 because only 41 and 43 has the value true assigned to it. Okay, next is filter array more than 42. Okay, filter array more than 42. So array is declared, filter array is equal to array more than 42. It only picks the element that are more than 42, which is basically 43 and 44. So new array is equal to array of filter array, which is basically going to have 43 and 44 alone. That is what you see here as well. Okay, next is we have seen here we are using the filter condition where array.0 is equal to 0. and we get the 2, 4, 6 with what are the elements that are even alone. So this is basically what NumPy is like. Mostly it will be targeting only on arrays, but when you get into some practical use cases of actually implementing things for data analysis, all of that, based on the different data frames and different data sets that comes to us, the complete approach towards using this NumPy and pandas would change. So probably what I would do is I will take some sample data set which is like very interesting to actually do some analysis, and I will share those analysis by applying some Python, pandas and NumPy functions. Okay. So apart from this, the next lecture will follow to have some NumPy statistics as well, which will cover some normal distribution, all of that distribution stuff, normal distribution, Gaussian, binomial, multinomial, all of them would be covered in this in the next NumPy, which is basically statistics version of the NumPy library. Okay, and next will be kind of pandas and matplotlib. Once you are clear with all of these libraries, this is much more sufficient to analyze any kind of data with Python. Okay, so see you in the next video. Thank you so much.